Hey, what's going on, guys? Games here. Last video we ended up implementing the run command intended to move the instruction pointer via the for jump to where the command file segment is located to actually run whatever a bytes weighted input from the hex editor, right? But here is the trick. Let's say you've been writing some code in machine codes and you actually want to save that. So if you don't save that, the next time you boot your computer, there would be zeros again in that memory, and that's a bit of an issue because all your work would get wasted, right? So in order to avoid that sort of a scenario, we can create a save command that would be storing whatever bytes you've typed within the hex editor to the USB flash drive, to the storage device we're booting from. So let's kickstart with so that's part 18. Okay, so let's just run our operating system. So here, so edit, let's say 0500 and wait input some bytes. Okay, we go back. So I can't run them because, well, I could have run them if this was a real program, as has been demonstrated before. But the problem is that if I run again, so, well, let's say I just close this and I just run again, and you see like there is nothing left there. Okay, so, and because we didn't actually store anything. So the idea what we're supposed to be doing in this video is to provide several user-defined programs. I will now try to explain why exactly, not just entering the file name and storing that, but just having the predefined ones. Well, that's because we're not having an operating system and like what people usually think about it. So instead we just have a list of the files, and if we have a look at the file list, so here it is. Okay, so here we have just the commands. So, well, probably we'll start by, let's start by creating a draft for a save command, and then we'll add this user-defined programs, and then implement the save logic. So, without further ado, let's actually start. So here, instead of bricks, I want to have the save command, and it should be 8 bytes long. So 1, 2, 3, 4, 1, 2, 3, 4. All right. Okay, so now in the build chain, so here I want to concatenate save.bin. Okay, so no more games. we have overwritten all the games with the system commands, but it's okay. So let's create a new file. Let's call it save.asm. And I would be using, apparently, well, I could have used run for boilerplate code, basically. Yeah, I think, no, I would rather use list, because yeah, it already has almost all the things we need. Yeah, so let's better use list. Save, so this is gonna be the save command. Alright, so we're not loading any sectors, so we don't need, so everything goes after initializing the stack. Just comment this out. We don't need the print files routine. We leave the print string routine, and read sector will turn into the write sector. And in order to do that, well, let's first leave it as is. And I just want to assemble it. So here, save asm and save bin. All right, so let's just so jump back to the shell, and here let's say move ascii just a string some point. So let's say define byte save command. Okay, so new line, we can have that, so we don't need this offsets. Yeah, we don't need the file offsets. Do we need a new line? Well, let's skip it. So whatever, add the save command and call the print string. Alright, so now list, so we have save here, and if I type save command, yeah, and I just want to print a new line after, but yeah, it doesn't, gotta make it like just this new line, character and the carriage return. So save, and now we got a placeholder for our save command, which is good. Yeah, and now let's go for a memory map, so to see how exactly this is gonna be working. So instead of bricks, we now have the save command. Okay, and now let's say, so yeah, I would need a calculator to get the offsets. So now let's say here, so how many? I think 5 user-defined programs would be just fine. So user just enters which user-defined program he wants to store his work to, and that's pretty much it. Okay, so let's say 0. No, we want hexadecimal 0 C 00 plus 200s E00. So here we have 0 E00 0x. I'm just specifying the plus 200s. So this one would start from 1000, and here -1 F. So we have 512 bytes, and let's call it program 1. By the way, it's 1, 2, 3, 4, 5, 6, 7, 8 bytes, which would be exactly the same as the file name for it. So let's go sector 8. Okay, sector 8. Yeah, and basically, yeah, I just can copy and 1, 2, 3, 4, 5. Yeah, up to 5. I think this should be fairly enough. Program 2, 3, 4, and 5. And here, sector 8, 9, 10, 11, and sector 12. So this is just a memory map. It's really useful to keep track of the memory map, to just remember how exactly you specify things. So the layout is important here. And now, yeah, just let's adjust the addresses. So 1000 for 1000. Now let's say 1000 hexadecimal plus 200 means 512 bytes in decimal, and this is gonna, let's just first calculate this offset. So I think it would be just, yeah, plus 200s. Yeah, so this would be like this, and now 1000 and -1 11FF. So here we have 11FF. Now -1 13FF, and this I guess would be 15FF. Oh, hold on a sec. Nope. Oh, so yeah, sorry, this should be here. Okay, and then hold on a sec. Oh man, what have I done? What have I done? Yeah, so yeah, again, start from scratch. So 12. Nope. -1. 11FF here. Then here 13FF. Yeah, and here, yeah. So 14, 0, 0, -1. Okay. And 16, 0, 0, -1. So this should be 15FF, right? Okay. And so 18, 0, 0, -1, 17FF. Yeah, it's logical. Okay, so here is the layout. So 5 user-defined programs. Okay. Okay. So probably, can we actually specify that somehow? So user-defined program. Okay. Okay, so seems nice. All right, so and now we want to have this as the files. So there would be 2 ways of running them via the run command and just like whatever other app, but there would be a bit of an issue with the current segment. The code is running at, so if this would be the 500s hexadecimal segment, or if this is, but that's where it's going to be running via the run command, and if we run it just like any other app, it would be loaded into the boot sector, and probably in that case, not probably, definitely in that case, the segment register, like the ES, should be altered, right? But we can also write the code that doesn't rely on that. So yeah, it's all on user basically. So let's say program 1. So 1, 2, 3, 4, 5, 6, 7, 8 bytes. Great. Program 1 defined byte. Program 2 defined byte. Program 3 defined byte. Program 4 defined byte. Program 5. But currently, sorry, I just yeah, I don't need commas because, but oh man, hold on a sec, it's a bit of an issue. Yeah, it's not the good way. So I need the 0 terminating character anyway, and in that case, yeah, the name should be, so I need to get rid of 1 list. Well, let's say prog1 like this, prog2, prog3. So 1, 2, 3, 4, 5, 6, 7, 8. In this case, yeah, we'll go for, because we need the 0 terminating character anyway. And yeah, let's rename. Okay, so now it's much better. What else? What else? So we can try to run this. Okay, so now, oh, whoa, I'm wondering why don't we have, oh, that's because I didn't link them. That's the reason why. Yeah, so let's also create some placeholders. So new file, let's call it prog1. It's not essential, or hold on a sec. No, well, actually, hold on, guys. We don't actually need doing that. Delete. So hold on a sec. I think this should appear, but no. Well, this is an interesting question. So, well, yeah, the reason why it doesn't appear in the list is because we didn't concatenate that. So if we do concatenate them, so let's say, yeah, let's just give, I don't know, whatever binary one more time, right? So now it should print prog1, or is it? List? No, it still doesn't. Hold on a second, guys. I feel a bit confused. So why is that happening? Oh, yeah, that's happening because here is the deal. Yeah, here is the deal. That's because we need to go to shell, and I need to add the offsets. That's the reason. So where is the shell? Oh my god, where is the shell? Here it is. So here down below, here it is. So files offset, copy, paste. And hold on a sec. Can I just? Yeah, I can just define words. Okay. So I just want to make sure that it still works. Okay, say edit. Yeah. And now define word and paste. So the prog1 would be 4 multiplied by the offset. Now it should print the prog1. Doesn't print the prog1. Why? Because we have an error. 178. Still don't. You guys just hold on a second to figure out what's wrong here. Okay guys, it seems like I figured out what's wrong here. So the problem is that we currently have, so in the shell is the matter of finding this specific file. So prog1 apparently should now be found, but it's not displayed. So if I say prog1, it finds the prog1 and even tries to run it, even though there is nothing there, just hands. It's a bit strange why, but anyway. So let's say if I just kind of like say prog2, it says like file not found. Okay. Yeah, but I'm just wondering. So did I break something in console already in the shell? Oh, it seems like. Okay, what did I break? Okay, so if I just restore everything to how it was, all right. Okay. Okay guys, sorry, just found a couple of bugs here. So first we want to have a zero terminating character after the new line, and also but this doesn't help yet, so probably want to, well, we could, hold on a sec, if I just put new line carriage return, okay, no file found, yeah, an out list, yeah. When I've been improving the list command, I broke the shell a little bit, so now with this new lines it should be just fine. But anyway, so the problem is, so let's say I just try to write the prog2, file not found, but prog1, oh, it's also not found. Okay, that's because yeah, I just restored everything. Okay, so one more thing, so I just want to make slight changes here, so it's no longer a next game but the next file, right? Replace all, run. Oh yeah, that's the problem. I want to get rid of this, this nasty space. Okay, well, I'll find a way on how to do that. Okay. All right, so yeah, probably, so okay, if I just, sorry guys, so you don't really need to care much about this, but so when I hit enter, when I return to, probably if I just print a new line here, okay. Okay, yeah, now this is good. So here we want to point ascii to new line. Here we want to print new line, and the reason why the new line was working still without this zero terminating character, because of this zero terminating character here. Okay, and now the offsets. So finally, yeah, you're doing something and then you're forgetting what you've been doing, and it's a bit of an issue, but never mind. So I want to go for multiple line definition like this, so it should still be the same. List edit. Okay, and now let's say define word, and now for, okay, and in the files we still have, yeah, we have this prog1 in the files. So we can't see this yet because of the list command doesn't yet have this offset, we've just added to shell. But now if we type prog1, it doesn't say that it's not available or something, just stuck forever, because there is just all the zeros, no code to execute there, right? But we already can run the prog1, which is good. Okay, so what do we want to do now is the following. So let's add all the offsets for all the 5 programs. So like this, prog1, prog2, prog3, okay. Oh, or we can even go for, well, just probably to, yeah, you know what guys, so just to make a bit more sense in the commentary, so you get an idea what is this all about, we can make the following thing. Define word. Yeah, would it be much better, I believe. Okay, at least way more clear. So yeah, it's a bit not the same offset for commentaries, but yeah, I think we can survive this. Hold on. Okay, so just move the commentaries one indentation to the right. So the first file is list, and here we have edit, run, save, edit, run, save, and then we have prog1, prog2, prog3, prog4, and prog5. 7, 8, save. So from now on, so still not available within the list, but prog1, and it is there. We just stuck, but it is there. Okay. Then prog2. It is. Oh, wow! Why prog2 is not found? Prog3. Hold on, guys. This is strange. This shouldn't be. Save command works. Prog1 works. But what's wrong with prog2? Oh, that's because, yeah, we don't yet have them here. Okay. Now we have. So prog2. And we stuck because it is there. And prog3. And we stuck. Great. Oh, sorry. And prog4, and okay, and prog5, and oh, what have I done? Prog5, and we're also stuck, which is awesome. Okay, guys, so now in order to add this stuff to list, we can simply grab this offset map and put it to the list, because list does this stuff kind of like by reloading. Yeah, here is the point. When I've been improving the list command, I thought that we would be dynamically adding this, the files, but then I decided not doing so, and from this kind of perspective, it seems like already a bit of a redundant thing to read the sector every time. So hold on a sec. If I just disable the read sector, maybe I don't even need to do anything else. No, that's because I still need, because yeah, hold on a sec. I still have this in a boot. Yeah, I do. Yeah, as a matter of reading the sector, doesn't matter. We can actually avoid doing that, so we no longer need read sector here, and probably we'll just get rid of that. Yeah, but anyway, we need to grab this offsets and files list and put them here. So from now on, let's get rid of the read sector as well. And don't need the file address anymore. What? File address undefined. Oh, yeah, still shouldn't get rid of the file address. Okay. And now let's display all the programs we have. Awesome. Yeah, call print files, and yeah, get rid of the read sector. Just fixed the comment tree layout. Okay. Yeah, so seems like this is it. So yeah, we always need to have this offset layout in the list ASM and in the shell. In the shell, we needed to be able to run the files. So we still do compare with all the guys here, and in the list we need them just to print them out. That's pretty much it. Okay, what else? What else? So now the only thing left is actually to make our programs, just to be able to store something there. Okay, and I would even probably try to manually, oh, if I do it, just, yeah, it doesn't work because I thought I could have manually write these programs, but if I build again from scratch, it won't work. So yeah, I probably will create some placeholders for them just to give user a message like an empty prog and store as prog1 whatever code you have at 500ths hexadecimal, and in that case, yeah, you can then run this by the load command that we're gonna be doing in future. Or should we, or is that a redundancy? Or no, we need the load command, the wrong command, not, okay, forget that. So let's get back to the save. And why do I have save bin here? Well, that's because I didn't remove it yet. So here we'll also add 5 placeholders for prog 1, 2, 3, 4. Okay. Yeah. But now let's get done with storing. So save. Yes, run again to clean up the binaries. Okay. Oh, and run.bin is not being cleaned as well. Okay. Yeah, only hello bin, which serves as a placeholder. We can get rid of this, by the way. No, for now, let's skip it. Let's skip it for now. Save. Okay, so read sector we turn into the write sector, and we need to change the code to 3 according to BIOS code. So I just remember this by heart. So we need to put 3 to AH in order to write to the flash drive. So hexadecimal 80 stands for like HDD. So the USB flash drive is treated to be like a hard drive. It's not a floppy. In floppy it would be 0 if I'm not mistaken. Then to initialize this, to initialize, so right sector, so print string failed to right sector if anything. And now to make it actually happening, yeah, we need to point bx to what to store. So now this is the source address in memory. To write to USB flash drive. Now this is going to be taken, adjusted depending on the user input. So we just, okay, so here one just to write the sector. Sector on USB flash drive to write data to. Okay, right sector. Okay, print false. What the heck is print false? We don't have it here. Okay, well, yeah, let's start by the proof of concept then. So memory map, so let's try to write to sector 8. So let's start by hard coding this value. So sector 8, if I type save, so say, let's tell the user the bytes at 512 bytes, starting from, now let's say bytes at, and just add the range. From this address and up to this address, has been written. So we don't specify which sector. That's just, just has been written to USB flash drive. Okay. So now the moment of truth. So okay, now let's say, oh guys, I'm sorry, I shouldn't, yeah, I actually still need in the list, yeah, I still need, I need to reload because otherwise I'm not gonna be able, yeah, oh man, that was weird. Yeah, I just hold on, just fix this stance here. Okay, so I've just restored the logic to read the sector within the list, because otherwise after we write we don't have the updates, right? So we need to make sure that we do have the updates. Okay, yeah, we need to make sure that we have the updates. So list, and now if I try to run the prog1, it's stuck, it stucks, right? But on the other hand, and let me also have a look at hello.bin. So I need well, I guess these bytes are enough to jump back to the console, so we'll now figure out if that is enough. So let's say edit and 0500 EA 004008 and go back and run, and we go back to console. Good. So now if we save, okay, so written to USB flash drive, and now if I say prog1, it should just go back to console perfectly well. So which means that we did write this byte to we did write this byte to the sector 8 just to prove that. We can just clear and let's say xxd GameOS dot image and just go into the beginning. So the sector 8 should be here. Oh, I did write, but I've written I've written the file list. Okay, I just written the file list, not the bytes, because bx is pointing to file's address, and it should point to, let's call it command file. Command file. There's gonna be a segment. No, address. Command file address, and copy and put command file address. So physical, this would be where our executable works, physical address memory to save executable from to USB flash drive. Okay, now this should be just okay. So now we actually now we have to, I think we should now be storing exactly the bytes. So list edit 0500 and EA 0008. I guess this is what we need. So let's check, run, yeah. And now if we save, so writes the bytes. Now it really writes within this address range, the 500 volts bytes for this address range. For before it was writing the from the address range from 7E00 to plus 512 bytes, where the file system, where the available files are located. So that was a bit of an issue. So from now on, if we now just clear and have a look at the GameOS memory dump on the USB flash drive, now we should see here our bytes. So here are the bytes that we've written for prog1. So here is the prog1. Here are the bytes that we've written. Okay, so these are the bytes. Perfect, yeah. So we did store it, and by the way, I've been testing this on the real hardware. It works as well. So yeah, this is really cool. Okay, so now it's capable of storing whatever bytes we've typed within the hex editor to, now in our case, to the hard-coded sector, but we want to let the user, let the user choose sectors from 8 to 12. So, but for user we'll say 1 to 5, and then we would be adding whatever user has entered to to CL, I believe, right? So CL should be equal to 7 by default. Okay. CL should be equal to 7 by default. Or maybe 8. Because if user doesn't type anything. Yeah, maybe let's make it 8 by default. So let's say prog1 is default. Call right sector, and now so here point ascii to, let's call it success message. Success message. Okay, copy to success message, right, and print success message. Okay, so here before writing the sector, we want to say move ascii, let's call it select sector. We'll now create this variable sector, so point ascii to select sector variable, and call print string, print select sector message. So here let's create select sector, define bytes, and here let's say type 1 or 5 to store bytes from memory to prog1, prog5. Doesn't sound that brilliant yet, and we want to move AH0x00, so this is the BIOS code to take a user keystroke to wait for a keystroke, and 0x16 do it. So how to say this? User input, wait for user input. Okay. And now let's compare AH with 0x01, which is escape key. So define escape key, scan code, escape key. So did user press escape, jump equals to return. If so, then return to shell. Okay. And here I think this should be okay. So yeah, if it just prints escape, it doesn't store anything, just jumps to shell, and we'll need to make sure that this is really what's happening. Jump equals return. Otherwise, we do this stuff and also return. So let's now check. So let's go for edit. Let's add some bytes. Okay, now let's save and escape. Oh, hold on a sec, I just have the error there. Okay. 25 invalid combination. What's wrong here? Whoa. Well, first of all, like this. Code and operands. What's 25? Ah, that's because I didn't. Yeah, I didn't define this. 0, 1. Save type 1, 5 to store bytes from memory. Okay, this is good. So yeah, it's a bit of an improvement. So let's make it new line 13 and define byte 0 like this. I just want to make it looking nice. Maybe okay guys, just hold on a sec, I found a better way to name these variables. Okay guys, so let's allow the output be something like this. So we press escape, go back to shell, but I just want to have a new line there. Yeah, by the way, why do I forget to print this 0 terminating character all along the way? It's a bit weird. So here, before return, let's say move ascii new line and call print string. So point ascii to new line variable. Okay, and print new line. Okay, so this is almost it. So let's have a look. Save. So no, I don't want to save anything. Go back to shell. But what if I want to save anything? If I want to save anything, so before calling the right sector, now let's actually can we just wondering. Hold on, guys. So, well, anyway, the first thing we want to do is to turn the user, the digit entered by the user from the ASCII code to integer, right? So we need to subtract, well, we can subtract 0 like this. So AL would be what the user has entered, right? So if I say subtract from AL 0 and plus, yeah, I can do like this, plus 7. So it would be, yeah, this is it. And then move CL to whatever at AL. So here we want to convert ASCII to integer. Here to integer plus 7 files offset before prog1. So here's where the offset comes from. So we need to make an offset for these sectors. So let's say the user enters 1. This turns into 8. 7 plus 1, 8. 7 plus 2, 9, and so on. All right. So in here we want to init sector to write bytes to. All right. Yeah, I think this is it. And then we write the sector. Okay. Yeah, let's try this again. So edit. So 0500. So let's initialize the data that we're going to be writing. So this data, for instance, is going to be like for or no, let's say A 0000. So let's say the prog1 would contain A's, prog B B's, prog2 B's, prog C C's, and so on. So let's get away from here and let's try to save. So I want to save this as prog1 failed to write sector. Whoa, 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 whoa. That's probably because the sector is malformed at some point. So okay, instead of well, in this case, let's try to see what we get at CL or at AL at least. So let's not do anything here for now. So how to print this? So move AH 0x0e to print the character. Move AL, what we want to print. Oh, we already have that in AL and int nh hexadecimal time. So we'll now see what we have. Well, how can I know that is the ASCII character for... Okay, let's just... one more little experiment. The smile face should be ASCII 1 or 0. Nope. Oh. No, it's 1 because it's the ASCII value. Yeah, so if I subtract just a 0, this means subtract 48 in decimal because that's the value for ASCII character of 0. Okay. Yeah, this smiley face I've been talking about, so it should be like 1. Or is it? Let's have a look. So ASCII. Let's have a look at the ASCII table to make sure. Yeah, but I need the symbols. So where are the symbols? Oh, they don't even print the symbols here. It's not great. Okay, in this case, okay, we can do another trick. I know, guys, this video gets really long, but well, I don't care because I really want to bring it to the end. And yeah, this is just live coding session, so it should be okay. So ASCII 0, 1, 2, 3, 4, 5, 6, and up to 7 and 8 as the first there. Okay, and 0 again. Oh, if I start with the 0, it won't be working. So if I just say like move ascii ASCII, call print string. Whoa, okay. Okay, so 1, 2, 3, 4, 5. Okay, 1 is nothing there. Okay, so this is 2, 3, 4, 5, 6, 7. All right. And whoa, it should be even up to 8. So maybe the first are not being... Okay, let's start with 2 maybe. Okay, 2, 3, 4, 5, 6. Oh, they just probably just not printable characters. Oh my god, what am I gonna be doing here? Yeah, yeah, the problem is the entire issue is that I can't easily figure out what exactly we have. So I thought that just adding 7 is okay, but is that so? Or plus... Oh, hold on a sec. Hold on a sec, guys. I think it's much easier to fix than I think. Probably I need to say -7. I'm not sure still, but probably okay, so let's just see it by hands. So let's say AL is equal to 1. Then in ASCII, this is going to be 49, right? So let's quickly check this. Yeah, it's 49. Okay. So oh my god, I'm so bad in math. So 49 minus 48 is equal to 1. And yeah, we need to add the offset of the 7. We definitely need this. So would it be eventually 8? And how many I need to subtract from 49 to get 8? 49 minus 8. Oh my god. I'm so ashamed, guys. I'm so ashamed. Okay, just hold on a sec, please. Okay, yeah, it seems like we just needed to subtract 7, not adding the 7, because yeah, that's how we can, by subtracting 7 from this constant, we actually add this 7 to the eventual output value. Yeah, now it works properly. Okay, guys, I'm sorry. I just yeah, it's really weird, all this tiny little calculations. I'm extremely bad in math. Okay, so let's go for a final test, hopefully the final test. So go into editor and let's enter the value AAAA and go back and save as the file 1. Then let's go to the editor 0 and let's enter BBBB. Okay, then go back, then save as the file 2. Sorry, save file 2. And we also need to print whatever user prints there. Also going to be a good idea, but that just to be added later on. And let's take the last one. If that works, then everything else is going to be working as well. So edit 0500. Let's say FFFF, back, save 5. And now we should have A in prog 1, B in prog 2, and AAAA, BBBB, and FFFF in prog 5. GameOS. Alright, so let's inspect. So this should be the save command, I believe. Okay, BBBB. Okay, we have AAAA at E00. By the way, it should match really. Yeah, it matched. So this address here is this address here. Okay. Then file 2, 1000. So what we got here? We have BBBB, which is okay, which is correct. And then skip a couple of segments, and the last one, 1600s. Yeah, prog 5, 1600s. We got. Okay, so save command works. This is good. This is awesome. One little more thing to consider within the save command. I just want to. So before writing a sector, And actually, before doing anything to the AL, I want to print it. So move AH0x0E. So this is the BIOS code to output character to screen, and int hexadecimal 10 print user input to screen. All right. So let's go to editor and let's enter our return 001234008, and let's store it as, let's say, proc3. Oh, I need to add a new line. So success message 1013, new line, character carriage return. So one more time. So if I just say try proc3, it stuck because there is nothing there. But now we'll try to write bytes to proc3 to return back to shell. So edit 0500 EA0008. So this is how we return back, and go back, save as the proc3. 512 bytes within this range has been written to the USB flash drive. Okay, so proc3 respectively, proc3, and now it should return back to shell. It doesn't stuck. Okay, so which proves that actually from now on we can write bytes to the certain procs. Well, there might be so like for debugging purposes, I would say we could have created some templates for this procs. So user, if let's say you want to try something, you can just replace the code in assembly and rebuild from scratch. So that might be on the cards potentially. And also it might be telling you like some intro message that the prog1 is not available. Like you can type it on your own. Okay, so probably, yeah, we will go for that. So let's create a new file. Let's call it prog1.asm, and where is my run command? Where is my run command? So it's prog1. So let's bring the print string there. Copy to prog1. Let's bring the print string, and let's give it a message, define byte. This is prog1 placeholder. This is use edit to input bytes. And let's say save followed by the prog number. Let's make it several lines, define bytes. So here, new line. To replace current placeholder, tb use save prog number to store respectively. So placeholder, use edit input files to replace it with your own custom app. Let's say use save followed by the prog number to store it as prog 1 up to prog 5 respectively. Okay, and prog 2 would be having prog 2 here and so on. So here I want move ascii to message and call print string, print message, point ascii to message. And now in run I want to assemble place a user defined programs placeholders. So nasm -f bin prog1.asm -o prog1.bin, and I want to make it for all the progs 2, 3, 4, 5, and let's make the cleanups like this. Yeah, let's say prog1.bin prog2, 3, 4, and 5. Alright, so cool. And now I just want to ufile prog2 asm, ufile prog3 asm, prog4 asm, prog5.asm, and now everything from, well, Okay, so I cannot, so I need to figure out if the first one works properly in order to avoid producing bugs in case if there are some. Oh, whoa. Prog1 and terminated strain. Whoa, 37. That's what I was talking about. 37. Whoa. 10, 13. 10, 13, 0. Okay, so prog. Yeah, it doesn't work because I believe it doesn't work because of an offset. Or hold on a second, no, actually. Well, this should actually be working. Oh, I need to jump back to shell. What have I done? Shell segment, just like in hundreds. Okay. Return to shell. Let's try again. So prog1. Man, what's wrong with it? I have no idea. Doesn't give any errors. Oh, I didn't concatenate them, that's the reason. I didn't concatenate them. So prog1 dot bin okay, it just jumps back, and if we ask it to print something, this is prog1 placeholder. Use edit input bytes to replace it with your own custom app. Use save followed by the prog number to store it. Okay, let's get rid of this respectively word. Doesn't fit the width of the screen. Okay, so list prog1. Okay, and now let's say I want to copy this to prog2. So this is gonna be prog2. And here we have, this is prog2. So prog1, prog2. Why it still prints this is prog1? Must be kidding. Oh, why whatever? This is weird. This shouldn't be like that. You guys just hold on a sec, just need to figure out what's wrong here. Okay, that's because I was compiling prog1 all of the time. So now it should be fine. Okay. So now let's say prog1, prog2 gives us prog2, and starting from prog3 we stuck because we didn't yet provide any code for that. Okay, great. So prog1, prog2, okay. So let's go to prog3. So prog3, and go into prog4, and the prog5. Okay, prog1, prog2, prog3, prog4, prog5. Cool. And we don't have prog6. Okay, so now let's go to the editor and let's start replacing the content of the user-defined programs by simple return from what? From here, right? So EA00, oh, sorry, edit 0, so first the address and then the bytes, so EA00408, so to return back to shell, these are the bytes, and escape and save. So save for prog1. Okay. Okay. And now, okay, so now the prog1, it just returns. So let's go for prog2. It still prints the message, but once we save to the prog2 placeholder, if we run the prog2, it just the bytes are getting overwritten and so on. Okay, and now let's drop back, clear, and inspect the image. So it should be like the bytes we've entered at the progs 1 and 2. Yeah, so prog1, or no, probably, yeah, prog2 apparently. Yeah, prog1, prog2, prog3, yeah, prog3, prog4, and the prog5. Yeah, awesome, guys. So yeah, I'm sorry for it took ages to implement this, but again, like, this is just this was completely live coding. I wasn't doing any preparation, so that's how I developed this operating system when nobody can see me. Yeah. All right. So is this all I wanted to have? So yeah, list gets the stuff updated. So if I just use the prog1, gets the placeholder. Yeah, if I didn't, but hold on a sec, it's actually, I still can't get whether I really need that. No, probably I still actually I don't need the read sector, and this should be the same because it's just the matter of files. It's the matter of loading the actual code to the RAM is the matter of the shell. So yeah, sorry, this is one of the most weird, yeah, very weird, but I just don't want to have the redundancy here. So let's go to list. So if I try to not to read the sector, I'm just a bit tired, so I'm not sure. So it shouldn't matter. So prog1, we have it. Now let's go to edit. And save as 1. So the list shouldn't change, but when I type prog1, since the shell loads the prog, yeah, it gets updated. So yeah, so actually I don't need these complications anymore. Print false, I don't need to read the sector. I thought I do, but on the real deal I don't, because the files are not getting changed dynamically. So I made that sort of a simplification, so to avoid dynamic change of the files. Okay. Yeah. Wrong one. Okay. Edit. Yeah, I didn't type anything. Okay. Save. prog1. Yeah, and we just return. Okay guys, so I think now this is really it from my side in regards to this tutorial. So I'm sorry for it took kind of too long to get done with it, but yeah, I was just thinking of the design on the fly. I had some basic ideas in mind, but when it came to the real implementation, it did depend on some circumstances I couldn't see when I just started. Okay, yeah, that's pretty much all about it, I think. So yeah, this is it from my side, guys. Thanks for watching. Until the next time, and take care.